Morning, everyone. No Booth Dog today, just Mr. Boothman. I'm sure you've seen by now the news that our school year has been canceled, in the sense that we won't be back in the classroom through the end of the year. We will continue through the end of the year in this manner. I really just wanted to reach out about that. I know I'm going through a lot of emotions right now regarding that, and especially all of my seniors. I can't imagine. Um, just know that you're not going through this alone. Okay, our whole society is being upended by this, and we are here for you, no matter what you're feeling or what you're going through. Um, I don't have any easy answers. I don't have anything I can say that will magically fix this or make you feel any better about it. It's hard. It's really unfortunate, and I know many of you understand the severity of the situation and why we have to do this, but it doesn't make it any easier. Just continue to push yourself here through to the end. I have said before, I've said quite a bit actually throughout the year, that one of the things I love about when you all complain about how hard my classes are is, by design, I need you to experience that struggle and that challenge, because I know I personally didn't experience that challenge until college, when I didn't have a very good support system yet. I didn't know how to persevere through something that was so difficult for me because I'd never had to. I don't like this situation any more than you, but crises and challenges like these give us the opportunity to see who we are. I jokingly ask some of you when you complain about how hard a test is, are you the kind of person who gives up? Are you the kind of person who just, shuts down? Is that what you're going to do in your life when you encounter a hard situation? Here's a hard situation. Are you going to push through to the end of this with the same tenacity and passion that you had before? Or are you going to give up? I can't answer that question for you, but my hope is that each and every one of you answers that question in an authentic, reasonable way. I'm here if you need anything. I don't like not being able to see you guys, but we'll get through this together. Stay safe. Let's start our lesson. Happy Tuesday. Let's look at our announcements before we finish our last day of Unit 8 review. You have an exit ticket due by midnight tonight that will ask you to submit any questions you have from this review in particular. Tomorrow morning, I'll check those. I'll put together some answers to your FAQs, and I'll post that so you have those answers as you take your Unit 8 exam. Unit 8 exam tomorrow. Again, there is no unit tracker due with this unit. Today, I'd like you to finish that Unit 8 review that I posted yesterday. Check your work with the answer key that was also posted. Right now, I'd like to go through one example from each section, 8.1, 8.2, and 8.3. And then, of course, if you have additional questions, you need a little more detail or clarification, join our Google Meet today, all right? So let's start with an 8.1 question. I'm going to do the very first one. It is simple, but the way that I approach this problem is how you will always approach these accumulated change problems. So please, please, please be very careful and see what I do. A particle moves along a line so that its velocity from t equals 0 to t equals 5 is modeled by this function. And they want us to find s of 5. Remember that s of t is our way of writing position. Okay, position is either s or x of t. So they want our position at 5. If we want our final position at t equals 5, remember this is how all of our accumulated change problems work. Our final position equals our initial plus the integral of our rate. In this case, our initial position they gave us our position at time t equals 1, which means our rate is going to be the integral of our velocity from this initial to our final time, 1 to 5. So whatever I decide to call my initial, whatever condition they've given us as our initial value, then when we take the integral of our rate, we're going from that point to whatever our final should be. So they could have given us our initial position at 3. And then our rate, our integral, would be the integral of velocity from t equals 3 to 5. Okay, so note that that changes. It's not always 0 and then integral from 0 to our time. Now, this initial position at time t equals 1, they're telling us equals 4. And then we're adding plus the integral from 1 to 5 of t squared minus 0.2 t cubed dt. All right. And now if we do the calculations here, again, I'm assuming you have a calculator here. You'll have a calculator for the entirety of your exam. That's fine. 4 plus, this comes out to 10.133. So 14.133. There we are. Now our unit, feet. They told us velocity was feet per second. Okay. So that's 8.1. This formula right here, this process, use every time for every accumulated change problem. Now I want to look at a problem from 8.2. Let's do number 3. All right, so we have this graph here. We have two functions. We have the graphs y equals e to the negative x squared and y equals negative sine of 3x. All right. Again, you have a calculator for this. So if we want this area here, we are going from, well, we're starting at 0 and we're ending at this point of intersection. How do we find that point of intersection? Use your calculator, set the two functions equal to each other, and solve for x. And we get x equals 1.139. Okay. Then we need the integral of top function minus bottom function. So which function is on top? Even without a calculator, hopefully you can identify this. We know that sine starts at the origin and then goes up and then down. Since this is negative, that means it's been flipped over the x-axis, so it's starting at the origin and going down and then up. So this bottom function is our sine function. That means our top function is e to the negative x squared minus negative sine of 3x. And we're integrating with respect to x. If we calculate this, we get 1.445. Okay, so area between curves, this is about as hard as it gets. You have to find your point of intersection, set your two functions equal to one another to do that, and then integral of top function minus bottom function. All right, I want to do one more problem. Let's do number 1 in section 3. So this is 8.3 now. Find the volume of the solid of the region bounded by y equals x, x equals 0, and y equals x minus 1 squared plus 1. Okay. When it is revolved about the x-axis, let's draw this. Y equals x is this line right here. X equals 0 is the y-axis. Y equals x minus 1 squared plus 1. Okay, so this is, we have x squared, so it's a parabola. It is opening upward. It is shifted to up 1 and to the right 1. That's just using our rules for transformations. Okay, so technically, it's passing like that. So we have this region here. And it is being revolved about the x-axis, so it's going this way. Up out of the board, into the board, and through. We are revolving about a horizontal line. That means we should integrate with respect to x. We have the integral from 0 to this point of intersection here. So set our two functions equal to each other and solve. We get 1 of pi times big R squared minus little r squared dx. Big R, on the axis of revolution, which function is furthest away? It is our parabola. So we have x minus 1 squared plus 1, and that is squared, big R squared, minus little r squared, the function closest, is y equals x. Again, you have a calculator. 4.817 cubic units. Okay. Always works this way. So there's no trick on the exam. If you've been keeping up and you've reviewed and you remember 8.1, 8.2, 8.3, you'll be good. Okay. So join our Google Meet if you have further questions. Otherwise, please continue to practice and be ready for our exam tomorrow. Okay. Have a great day. All right, well, let me know if you need anything. Join our Google Meet later today. Please, 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 please do your work. Stay safe. We're here for you.